What's up, scholars? Today we're talking about proportions and similar triangles. Let's remind ourselves what a proportion is. What is a proportion, huh? Proportion is a ratio or a fraction that's equal to another ratio or fraction. That's a proportion. It's pretty cool stuff. And then similar triangles are triangles that are the same shape, but one is bigger than the other one. So their size is different. Cool. Alright, the triangle proportionality theorem says that if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. If a line parallel to one side of the triangle, so if we have two parallel lines that are part of those triangles, then it divides the two sides proportionally. So these parallel lines, right? This line, parallel that line, this line intersects the other two sides. So it's going to divide those two sides proportionally. So our proportion is going to be, actually let's write this out. If a line parallel to one side of the triangle, this line parallel to the other side of the triangle. So if TU is parallel to QS, then our proportionality situation, TR over UR, TR over UR will equal QT over SU. Pretty cool. We also talked about how you could switch the means and the proportion is the same. So we could also say TR over QT equals UR over SU. TR over QT equals UR over SU. Remember? So we could switch the means and the proportions are still equal. Cool. The converse, remember converse means we flip our if and our then. So the converse is going to say if a line divides the two sides proportionally, then it is parallel to the third side. So if our proportion statement is true, or the other one, then these lines must be parallel. TU must be parallel to QS. Great. Fabulous. Let's do an example. See if we can use that newfound knowledge we just acquired. Example number 1, in the figure below, BD is 2. I'm just going to go ahead and label it right now. DC is 2.5. EC is 4. What is AE? Sounds like I'm calling that X. Great. Let's set up our proportions. We could say DC over BD equals CE over X. DC over BD equals CE over X. Let's plug some stuff in. 2.5 over 2 equals 4 over X. And you guys know what to do here. We're going to cross multiply. X times 2.5 is 2.5x equals 2 times 4 is 8. And then we do little division. 8 divided by 2.5 is going to give us x, which is, what is that? 8 divided by 2.5 is like 8 divided by 5 over 2 is like 8 times 2 over 5 is like 16 over 5 is like 5 and 1/5 is like, no, that's not right, 3. 3 and 1/5 or 3.2. Yeah, that I believe. That I definitely believe. Fabulous. Why are we allowed to use that? Because these lines were parallel, fools. That's it. Those parallel lines allow us to set up that proportion and solve. Great. Looks like we have an on your own situation. In the figure on the right, AB is 25, BC is 10, ED is 8, and AE is 20. We're going to decide whether those lines are parallel, so I think we need to check out if the proportions are equal to each other. If we have a true proportionality, if the ratios are equal to each other is what I should have said. Find out if the ratio of these sides are equal to each other. If they are, they're parallel. If they're not, then they're not. All right, I'm going to leave that for you to do on your own, your big giant brains. And we're going to keep cruising on together. Ooh, look at these pretty pictures. Theorem 8.6. If 3 parallel lines intersect 2 transversals, then they divide the transversals proportionally. So here's our parallel lines intersecting our transversals, line L and line M. Then they divide the transversals proportionally. So UW over WY will equal BX over XZ. UW over WY will equal BX over XZ. That's pretty nifty. And you know what? This would continue on. If there were 4 parallel lines, we could add another one. If there were 5, 6, 7, 8. And they would all be proportional. Those parallel lines do some beautiful things. Alright, in Theorem 8.7, if a ray bisects an angle of a triangle, here's our ray CD bisecting this angle C, meaning splitting it perfectly in half, so that part, that angle, equals this angle, angle ACD. ACD equals angle DCD. Cool. So a ray is bisecting the angle of the triangle, divides the opposite side into segments whose lengths are proportional to the lengths of the other 2 sides. What? Divides the opposite side, here's the opposite side, into 2 segments, AD and DB, whose lengths are proportional to the lengths of the other 2 sides, AC and BC. Let's write out what we just said. AD over DB is going to equal AC over BC. Alright, so sounds like it's time to do some examples. Like example number 1. That's like a good idea. Here we go. You can see it all. Example number 1. An artist uses perspective in order to draw a row of parallel trees. She checks the drawing by measuring the distance between the trees. She finds that A to B is 2.4 centimeters. BC is 1.4 centimeters. CD is 2.2 centimeters. KL is 2.2 centimeters. And we're going to find LN and LM and MN. So for funsies, I'm going to call this guy X and call that guy Y. And let's set up a nice long proportion here. So we are assuming these lines are parallel. Parallel, parallel, parallel. Let's set up our proportion. So AB over KL. AB over KL is going to equal BC over LM is going to equal CD over MN. You can't see any of that, and now you can. AB over KL is going to equal BC over LM is going to equal CD over MN. Now let's plug in the stuff that we know. Let's go. 2.4 over 2.2 equals 1.4 over x equals 2.2 over y. Okay, we got two variables we need to solve for. Let's solve for x first. Let's just use those first two ratios. 2.4 over 2.2 equals 1.4 over x. Let's do some cross multiplying, shall we? 2.4 times x is 2.4x. 2.2 times 1.4. I'm gonna have to get out my handy dandy calculator, because I don't know that one off the top of my noodle. Maybe you do. That would be cool. 2.2 times 1.4, 3.08. And let's do some division. We'll get x equals, round to the nearest tenth, 1.3. And now we got to solve for y. We can use this ratio we have right here, and this one right here. So solving for y, let's do these guys. That one's going to equal that one. So 2.4 over 2.2 is going to equal 2.2 over y. Do some cross multiplying. 2.4y equals 2.2 times 2.2 times 2.2. 4.84. Let's do some division. Divide by 2.4. Divide by 2.4. Y is going to equal, round to the nearest tenth, going to be 2. Cool. That proportion's just the most beautiful. Yeah, they really are. They really are. Great. Let's keep cruising, shall we? I think we shall. Oh, look! It's your turn! That's fun. Find the value of x. Using the given values, I see 3 parallel lines. So that means these sides are going to be proportional. But wait, how long is this side? I mean, we know the whole thing's 10, and that chunk's 4. So you'll have to figure out how long that side is. Do a little quick subtraction. It's gonna be great. That one, my dears, is for you. Let's come back together and do an example 2. In the diagram, angle CAD is congruent to angle DAB. Angle CAB and angle DAB. Use the side lengths to find the length of DC. Oh, this is a good problem. Because we know, using one of the theorems we just talked about, that BD over DC is going to equal AB over AC. Let me write that down. BD over DC. BD over DC is going to equal AB over AC. But we don't know BD or DC. We just know that all together they're 14. So here's a little trick. We're going to call BD X, and CD is going to be 14 minus X. 14 minus X. Right? So if BD ends up being 4, we know DC is 14 minus 4, which would be 10. Let's see what happens. Now we can plug some stuff in. BD is X. DC is 14 minus X. AB is 9. AC is 15. We are becoming fabulous cross multipliers at this point. X times 15 is 15x. And then we got to do 9 times 14 minus x. Got to do all of that. So you have to do some distributing. Pow pow! Poo poo! 14 times 9. Great. 15x is 126 minus 9x. Then let's do some addition and get 24x equals 126. And then we'll do some division. So x equals 5.25. Great. So good. Hold on, that wasn't what they asked, though, was it? They said it was DC. Well, we solved for BD. That was 5.25. DC is 14 minus that. What's 14 minus 5.25? Exactly as I thought. DC. Don't need that on the top because we're just talking about the measure. DC is 8.75. Cool. Alright, you geniuses. You got another one. You're gonna work it out. Work it out. And, oh, that's it. That's it, kids. Go get them, scholars. I love you. See you next time.